Nuclear energy is considered one of the most important and modern sources of energy in the contemporary era. It plays a pivotal role in meeting the world's increasing energy demands. Today, this energy is used in various fields, including electricity generation, powering certain types of transportation, and even in medical, agricultural, and industrial applications. Despite its diverse uses and significant benefits, nuclear energy remains a controversial topic due to the potential risks it poses to public health and the environment, in addition to the high costs associated with building and operating nuclear power plants. In this research, we will present a comprehensive overview of the concept of nuclear energy, its origins, key advantages and disadvantages, peaceful uses, and the current global status of nuclear energy, along with a comparison between it and renewable energy sources. First, a historical overview of nuclear energy. The story of nuclear energy began in the early 20th century when scientists discovered nuclear phenomena such as nuclear fission and radiation. German physicist Otto Hahn is considered one of the pioneers who contributed to the discovery of nuclear fission in 1938, which became the foundation for later nuclear applications. By the end of World War II, nuclear energy had transitioned from military uses to a peaceful tool for electricity generation. The first peaceful nuclear power plant was established in the Soviet Union in 1954. Since then, the number of nuclear reactors has increased in various parts of the world, and nuclear energy has become a fundamental part of the energy strategies of many countries. Second, advantages of nuclear energy. 1. High energy production capacity. Nuclear energy is characterized by its high capacity for electricity generation with great efficiency compared to traditional sources. A small amount of uranium or plutonium can produce energy equivalent to thousands of tons of coal or oil, making it an effective option in terms of efficiency. 2. Low carbon emissions. One of the most notable advantages of nuclear energy is its low greenhouse gas emissions. Unlike fossil fuels, nuclear power plants do not emit carbon dioxide during operation, making it a suitable option for reducing climate change and global warming. 3. Continuity and reliability. Unlike renewable energy sources such as solar and wind energy, nuclear plants operate around the clock regardless of weather conditions, providing a stable and continuous supply of electricity. 4. Reducing dependence on fossil fuels. Using nuclear energy helps reduce the consumption of coal, natural gas, and oil, which in turn lowers air pollution and limits the ongoing depletion of non-renewable natural resources. 5. Efficient resource utilization. Nuclear reactions use relatively small amounts of fuel to achieve significant energy output. This reduces the need to transport and store massive amounts of fuel, thus lowering long-term operatio.
Six. Technological advancements in nuclear safety. In recent decades, there has been remarkable progress in safety technologies used in nuclear reactors, such as automated cooling systems and multiple protective barriers that prevent radiation leakage. These developments have helped reduce the likelihood of accidents. Third, peaceful uses of nuclear energy. In addition to electricity generation, nuclear energy has several peaceful and vital applications across various fields, including 1. Medical field. Radioactive isotopes resulting from nuclear reactions are used in diagnosing and treating diseases, especially cancer, through radiation therapy. They are also used to sterilize surgical equipment. 2. Agriculture. Nuclear energy is used to sterilize soil, eliminate agricultural pests, and improve crop productivity through ionizing radiation techniques. It also contributes to producing plant varieties that are resistant to harsh environmental conditions. 3. Seawater desalination. Nuclear reactors provide thermal energy used in seawater desalination processes, which is a promising technology for solving water scarcity problems in countries with limited water resources. 4. Scientific research. Research reactors are used to advance nuclear science, study materials, and interact with subatomic particles, supporting many scientific and industrial innovations. Fourth, disadvantages and risks of nuclear energy. Despite the many benefits of nuclear energy, it is not without challenges and risks that must be considered. 1. Nuclear waste. One of the biggest disadvantages is the radioactive waste generated by reactor operations. This waste remains hazardous to the environment and human health for thousands of years and requires long-term storage in secure and isolated locations. 2. Nuclear accidents. Despite significant advancements in safety technologies, nuclear accidents remain among the most dangerous possible disasters. The most well-known incidents are the Chernobyl disaster, 1986, in Ukraine, and the Fukushima accident, 2011, in Japan, both of which released large amounts of radiation and caused severe health and environmental consequences. 3. High costs. Building and maintaining nuclear reactors require massive investments, especially in safety measures and waste disposal. Additionally, decommissioning old reactors and dismantling them also demands substantial financial resources. 4th, potential military use. Nuclear technology can be used to manufacture nuclear weapons, posing a threat to global security and raising concerns about the proliferation of nuclear arms among nations or unauthorized groups. 5th, comparison between nuclear energy and renewable energy sources. When comparing nuclear